Hey, this video is going to be about machine learning. In particular, we're going to look at a couple of recent ImageSC questions. This first one, it's about an article from machine learning to deep learning. And the second one is on this challenging segmentation problem, which has been out there for a couple of months now. So the goal of the video is to take a deeper look at how machine learning performs on a couple of different image types. So this article was written by Zeiss, and they were sort of kind enough to share one of their images. And I'm always interested in these comparisons between classical image processing, machine learning, and deep learning. In order for the comparisons to be meaningful, we need to make sure like each technique is run like as good as possible. So in this case, I'm going to take a closer look at machine learning on these two image types, one of them SEM, an SEM image of grains, and one of them very irregular cells. So one thing I would like to point out, like again, I'm always a big fan of fair comparisons. This image of grains, I spent a little bit of time doing machine learning on it, and soon after I got a macro sent to me by Herbie. And this macro actually does a really good job. ImageJ macro, cut and paste, put it into ImageJ, no complicated dependencies needed, and you get a nice result. So this SEM image may be actually a case where even machine learning is overkill, and you need to go to just some classical image processing. Now we don't know that for sure because we to really know what technique works best, we have to test on like a larger image set. So that being said, I am going to do machine learning on this, and my machine learning examples are 99% written by Kyle Harrington. I just basically cut and paste this notebook that he has, which is a interactive segmentation tutorial. I made a couple of small, kind of cool modifications, which I'll get to in a minute. But if you want the code, my sort of vendored modified code, it's on my TNIA Python site. I have a notebooks directory where I keep an image C directory where I keep track of work I've done on various problems. And this notebook, you can find it in the 224.12.19 grain directory, and also the version for the tough cell pose irregular cells problem is in 24.10.11 tough cell pose. But honestly, if you do want to run this stuff, feel free to like post questions on the message board. Yeah, anyway, so you grab this code, put it in your IDE or your Jupyter Notebook viewer, and yeah, it should all run. I don't think I have any dependencies to any of my utilities. The only thing you may have to change is the directory to the images, and the images are available on the forum questions, again, if you want to try to replicate this. Run all the cells in the notebook, and the cool thing about this notebook is within the notebook, it completely builds a Napari plugin, an interactive Napari plugin. So it's a really great resource to just learn about the Napari API, how to set up callbacks, and how to do other cool things. So what do we do here? What do we have? We have a machine learning plugin, and it's interactive. So as we draw, I'm going to go to this painting layer, and I'm going to draw a little bit of okay, if you're watching closely, you saw me screw up. I actually drew background on one of the grains where it should have been foreground. But anyway, the idea is we draw background and foreground. I've only drawn foreground right now, so I paused and redid it. So I'm predicting everything is foreground, but watch what happens when I add a little bit of background. Now I have some foreground, some background, but what I want to do here is try to separate the grains. So I'm going to have to draw some more subtle areas, some more like some of these fine areas of background here. Now you see as I start to do that, I start to get, whoops, this one is a little, that one's a little bit too much foreground on the background. So yeah, so as I draw these, I start to get a segmentation result, and I could see it update live, and I could see, how good it's doing. So the game here is just to keep modifying the foreground and background labels until you have things like sort of balanced, so that you have enough background and foreground examples that it can do a good job of creating these boundaries. And so the one wrinkle I added, 99% of this code is by Kyle, but I added an extra layer, an instance layer. So what the instance layer does is it basically does instance counting or labeling through the skimage labeling function it does it live on your live segmentation. So you can get a good idea of how are these boundaries actually separating objects? So what you're looking at here is machine learning. It's learning how to separate pixels into background and foreground, then doing an instance segmentation or doing a labeling so you know whether the boundaries are continuous enough to actually separate your objects. So yeah, I paused it for a little bit to draw some more boundaries, but you can see I've drawn some background, but I might have a little bit too much background, so I need to add a little more foreground. And you can see as I add one class or the other, the segmentation changes. And the game here is just to try to balance these so you get continuous boundaries, but not too much like clutter in the objects. So yeah, so you have to sort of just go back and forth between the two classes and keep on fiddling with it until you get a pretty smooth result. So yeah, so anyway, you keep on drawing, adding labels, balancing your two types. And you can see this is what I've drawn. This is the segmentation, and then this is the instance segmentation. And the result is starting to get okay. I think there's still a few boundaries that aren't complete here and there. You can tell that by looking for cells that are the same color. Let's see if we can fix this one here. Get this a little closer. Let's see here. So yeah, so there we go. I added in, there was a little bit, it was having trouble with that boundary. Added in a little more, added in another label, and it seemed to have fixed that one. And then sometimes the weird thing is some of these labels, it looks like they're the same, but when you actually hover over the pixel values, you can see that I think like these two here are actually different pixel values. So that, yeah, so this is not too bad. Let's try this one here. This one here doesn't look the greatest. So yeah, after some labeling, here are the labels. You get this segmentation in these instances, and some of them look like they're merged, but you actually, when you hover over, you can see that it unfortunately sometimes colors them the same, even if they're beside each other. So you sometimes have to hover over to see if the pixels are different. So yeah, this isn't too bad. That being said, I will, again, fair fight, the classical image processing did just fine on this image too. Okay, so that's the first example. So I'm going to go on to the second example, challenging cell posts or challenging cells here with irregular boundaries. Okay, so we got this image up. It's the same idea. This was, I just ran the notebook. The notebook generated an entire Napari plugin, and now I'm going to start by painting on the painting layer. So add some background, and we should see the whole image be classified as background because we don't have anything else. Start adding a little bit of foreground, and we start getting some cells with the instances. This is a tough one. We're missing the fine details. So one of the tricks of this one is a really tough one. One of the tricks is we need to start trying to label some of the finer details here. But as soon as we do that, all the cells really start merging together. And this one, it's really hard to find like just train a pixel classification model that can separate things. So let's see how it's doing on the whole image. I really haven't added much so far, and it's starting to do an okay job. Um, let's see what we got here. Let's turn the instances off for a second. And yeah, we're really over segmenting. We need to add more balance, more background here. Whoops, we got to turn the paintbrush on, add a little bit of background, and we start to see this improve a little bit. I think what I'm going to do is turn the video off while I add some of the label some of the small subtle areas. So you can see I'm labeling some of these subtle areas, but you can see the great thing about machine learning pixel-based is for these really fine areas, you don't have to draw like the whole filament, which can sometimes be tricky. You can just do individual pixels. So you can sometimes get the fine labels a little more accurately, because again, you don't need the whole thing. You just need individual pixels. So I'm doing some labeling here. Too much background, or too much foreground. Let's see here. Yeah, so one thing we can do is we can change, we have this prediction layer, but we can change the opacity if we want to see what's underneath it a bit more. And let's see here. Then it can guide us a little better. Yeah, let's try to get rid of some of this background. Then let's go back to adding a few more foreground pixels here and there. Yeah, I'm gonna again pause it just for a bit, because yeah, this is a little bit tricky to get all this. Okay, I started the video again. So what I wanted to show here is what's actually kind of interesting is when I sort of just trace this background here, it actually improves the result quite a bit. So now I'm perhaps starting to get an okay result. So let's zoom out to look at how it's performing on the whole image, and maybe change the opacity of the prediction a little bit. Yeah, so there's our result. Not perfect, but again, for real projects, you work on it way more than just like the few minutes of the video. So this one is tricky though, because it's really hard to separate things just by pixel segmentation. So one thing I'm going to do here is I'm actually going to use this. If I look at the instances, they're all together. So I'm going to use this instance painting layer to try to get some separation between the individual objects. So again, this is a little bit time consuming, so I will turn the video off for this part. So what I'm trying to do here is separate some of these objects. And it's really tricky because they're connected in all kinds of places. So I have my instance segmentation going, and when I finally get it separated, I should see this guy here change color. Okay, so I'm improving the separation a bit, but this is still connected to the rest of it somehow. And I can't quite honestly see where. Let's see. Okay, so I think it might be just here. There we go. So the idea here is that we use pixel segmentation to do foreground and background, and then we have to do some manual work to separate the instances. And then these instances, these could be labels. These could be used as labels to, for example, train a cell post model. I'm going to turn it off and do a little more separation. So yeah, the goal here is to try to find like where these are connected. And there you go. We finally separated this guy. So I think I'm going to run out of time here. And maybe not. Okay, so once again, it's allowed me to go a little further. Um, so that's good news. So yeah, so the goal here is, what we're doing here is we're doing this. So we have the painting layer and the painting cells. When we paint, those labels are used to train the model. We might get to a point where we say okay, we can't separate this just by pixel classification. So in this case, now we want to go on to deep learning. But we need labels for deep learning. So the use case here is that we first get our foreground and background, and then we start using this instance painting to try to separate the different instances, where then this could be used as a label for training, like for example, a cell post model. So what I have to do here is I have to start using this instance painting and keep searching for where all the connections are and just break them so I get these divided into different instances. And it's kind of tricky. There's all kinds of connections. So you could see I'm not really still not getting them all. Let's see here. Okay, yeah, so I just found another connection, so I'm starting to get better separation. Let's see here. Okay, so yeah, so you can see what the sort of goal here is. And I'm being a bit sloppy here, but the goal here is to like start really trying to separate these cells so we have labels which we can use for training cell posts. And it's really, there's really like so many like little connections that this separation is hard. But now you can see I'm starting to get it, and I'm just going pretty quickly. If again, real project, you would be more careful. So I'm taking a look at this. I think this, maybe I could try to separate right here. Still didn't get this guy. Separate right here. And these guys are still connected somewhere. Oh, right here. Okay, so you could see I finally am starting to get these into the different groups, and now you see it's starting to get there. And then these ones here, probably just by breaking some of these connections. Yep, you're starting to get a little bit, some differences right here. Ooh, these two guys are still connected somewhere. There you go. So yeah, so now you're getting towards a labeling that could be used to train cell posts. And again, it's a bit sloppy. These are complicated cells, and I haven't taken a lot of care because I'm just making I'm just doing all this in around 20 minutes. Okay, let's break this guy. And there we go. We got these guys now into two. So yeah, you slowly will get there. Like you slowly, if you carefully like look for all the divisions, you can sort of eventually arrive at probably a pretty decent like set of labels. So you use like the pixel classification to go foreground and background, and then you use like the instance painting to try to do the separation. And Napari like updates live as you like separate things. So let's see what we got here. I'm going to turn off some of these guys, and this is just our this is our label. So this process, which takes 10 to 20 minutes. And probably again, if you did it for if you weren't just making a video to demonstrate a tool and you're doing it for your real project, you'd spend more time. But we're sort of showing here how you could potentially use machine learning to aid your labeling, and this is what we got. We can make more corrections, make it better and everything, but maybe machine learning is a potential way to accelerate your labeling for this problem. Okay, so that's I think that's it for this video. I think this was a little bit some challenging stuff here. It didn't all go perfectly smoothly, I don't think, but in the end, I'm kind of pleased with what we got here. Um, anyway, that's it for this video. I hope you learned something. And again, any questions or anything, ask on the image.sc forum.